So this, so basically, as I said, if something is moving in a circle, we've just proven that it's accelerating towards the center, even though it's moving at constant speed, which is kind of weird. But now we know why, because acceleration is rate of change of velocity, not rate of change of speed. Now, and also if that's happening, if it's accelerating, there must be a force, and that force can be calculated by m times the size of this velocity, so technically that would be speed really, but we're going to use the same symbol anyway, squared divided by r, the radius of the circle. Okay, so I'll just label that as r. Now we're not going to go into why it's that. We're not going to bother trying to prove that equation right now. We're going to gloss over that bit, partly because I can't entirely remember how you prove it, but it's also, I think it's quite difficult to prove, if I remember rightly. So however, looking at that, we can see that acceleration therefore must be v squared over r. Okay, so v minus u over r, which is also going to be v squared over r. Got to make sure my r's and my v's look different in this situation. So let's just, yeah, they tend to, if you do this, the reason why we do this little thing there is to show it's a lowercase v. But anyway, so and there is another formula for force and for the centripetal motion, and that is m omega squared r. Now we'll go into what omega means a little bit more detail in a moment. For now, we say it's the angular speed or the angular velocity, and what it means is how quickly it's moving through this circle. So if you had a large circle, the speed, and let's say it takes 5 seconds to go around this circle. Well, and maybe in fact we had let's say this is there were lots of things moving around the circle. They all took 5 seconds to go around the circle. They would all have the same angular speed, but the ones on the edge would have a larger actual speed or velocity because they're covering a larger distance in the same period of time. Does that make sense? So this is why the formula is. This relates to why the formula is different. Okay. So we'll stop that video there as a brief introduction to this formula right here.